Can you see my screen now?
Yes, sir.
Okay, so let us start today's lecture. So before I start today's lecture, let me discuss something about quiz one. So I gave you two questions, and it was for 20 minutes, and then 5 minutes extra for like uploading. So how did you find the quiz? Was it difficult?
No, sir, but the time was not enough.
It was just two, and it was straightforward. I mean, it's not like the questions were very difficult, and you had to write a lot about the solution. So two questions for 25 minutes, almost 25 minutes were like I don't think that it was. It's not like none of you have attempted. Most of you have attempted both the questions, but you have attempted in a wrong direction. That's the problem. So
Yes,
as
sir.
I
That's a
mentioned earlier, yeah. So as I mentioned earlier that because you are, please keep yourself muted. Please keep yourself muted. So if you are not speaking anything, then please keep yourself muted. Thank you. So since you are in MSc, after 1 year or 2 years, you will be in PhD if you want to pursue PhD and in mathematics. And if you don't want to, if you don't know how to write, then it would be a problem. Also, how to start in a right direction. You should read the question carefully, and then you should answer. So the
sir,
purpose
but
of this, yeah.
sir, due to the time limit, sir, we were kind of nervous. So we were thinking that how should we proceed, and there is also time limit. So that was like kind of pressure on us. So that's why we
So
did.
yeah. So the two questions for 20 minutes for you. You're saying that the time was less.
No, sir.
No,
No, sir.
I'll keep in. Yeah,
Time was less. But I'm saying that there was a time limit. That's why we were nervous.
but
It's not
you
about
will.
that.
Yes, I understand. But in all the
So our
exams, you
writing
will have.
practice towards the question is also very bad.
Yeah, so that is what you have to improve. I mean, that these are the you are given tutorial sessions. In the tutorial session, you are supposed to like practice by writing the solution. And if you have any doubt, you should ask in the tutorial session or in the class, whatever. And I also mentioned that whatever doubt you have, whatever difficulty you are facing related to the course, you should ask, you should discuss. I'm keep on saying this again and again. So the questions
So
were very easy. It
so
yes.
sir, actually I am having very much problem in the proofs. Sir, I know the concept, I know the statements, but I'm not able to prove that questions.
Yeah,
I
so so that will develop by practicing. You should write the solutions of tutorial problems first. Then you should also like participate, or you should try to think about whatever or however I am proving in the lecture. So that's why I already ask you before starting something. I always ask what should be the way to start. So, or you can you still face difficulty, then we can like discuss. I can fix a slot for you for for some 30-40 minutes, and then you can like share what kind of difficulty you are facing. But things are that it's like it will only develop when you start practicing. Yes, you have to start practicing the tutorial problems, not only in this exam, not only in this course, but in the other courses also. Try practicing solving problems. You can solve the tutorial problems. You can you can like take any textbook and look at their exercises. This way you will start developing. But the thing is that first you understand the question, that okay, this is the question, and then what is available to us, and you think okay, these are the things available to us. You try to recall like okay, these things we have learned in the class, and then whether this can be useful, these things are enough or not. I will not only in this exam, in any exam in my course, I will not give any straightforward question. The questions will be very easy. I'm telling you, the questions would not be difficult, but you will have to think. It's not like you will get, you will like if you mug something, or if you like try to remember, or like if you try to um, collect this question from somewhere, then you won't be able to find,
So, but
most
how do you
probably.
handle the time limit pressure? Sir, that is
No,
too
the
much.
time, but see, in every exam, not only in this, in other competitive
Yes, sir,
exams
in every
also.
exam. That's why, sir, in school we used to mug up and then give answer.
No, no.
That's
So
how
yeah,
they.
you don't have to do that. So see, if it was an offline exam, I could have given. I was there in the. I would have been there in the like examination hall, and I would have given extra time, like to finish. Or this is like online thing, and there is a chance that I mean, not
So
everyone,
one
but there is a chance that people supply the solution. So we have to keep some time limit. We
yes, sir.
cannot give like
That's that is what that I understand. But, uh, sir, what I was thinking.
so what I will do in the
Yes,
next
sir. Yes,
exam,
sir.
I'll try to like give less questions. So it was like I thought initially, I was planning for four questions for like 40 minutes, or let's say 50 minutes. But then I thought that maybe let's see how you guys write. So then I gave only two questions for 20 plus 5, 25 minutes. So next time for two questions, I will keep in mind, I'll give 25 minutes, 5 minutes extra if there are two questions. Really, so if the idea is clear, then it should not take time. It should like follow. But then it only helps when when you practice these tutorial problems or exercises from some textbook.
So the
Otherwise,
problem.
like if you only solve problems in the in the exam, I mean, you try to write the solution in the exam, then it may not like solve the purpose, because it won't you won't be like efficient in solving problems, at least to think in the right direction.
So, but to think we need to be relaxed, and to be
Yeah,
relaxed, we are
yeah,
nervous.
yeah.
There is time
So
limit.
you tell me what should I do for this? I mean,
So
it's for
even
everyone.
like in
Whenever
computer
it's
programming, sir is giving us 24 hours to complete
who
the program.
who is giving 24 hours?
C++, VVK, sir.
No, no. So you understand these subjects are different, and also
So
if I
there is
give you like 20,
like
see,
there is
see,
time limit
in
pressure. We can relax,
wait,
do it in a relaxed manner. But here we are
wait,
not.
wait,
We are nervous.
wait. This will happen in every exam. If you start like thinking of 24 hours, you won't be able to clear other exams. This is your like shaping
So
you in the for your future.
so we will be able to clear exam, and we have actually. But these exam are like, these question are like we have not done like. So these are question new to us, and there's also time limit. So we get kind of nervous, like how to proceed. We have time, so we do it like whatever comes in our mind, we write it, and then the times goes on, and that's it. That's how we
No,
do.
but see, this is that's why I'm saying, so you have to start practicing so that you become efficient in solving problems. You have to practice, otherwise how would like you just solve problems in the exam, then it would be a problem, because then it will always be your like, not only you, I'm telling to everyone that if you think in this way, then it would be a problem always, not only this time. So it's that's why I'm saying that you it's normal, it's a human behavior that whenever we face some exam, or whenever we appear in some exam, we get nervous.
Yes, sir.
But
Yes.
it's a common thing. But then
Yes,
you have to hold yourself, think
sir.
about one
Sir,
question at a time, and then you solve. Yes.
sir, sir means I means personally I'm getting a lot of difficulty in uploading the answer in Gradescope, sir.
So but that how can I help in this case? I mean, you have
Sir,
to like see the technical thing.
at least you should give us a two or three platform where we have a means we have a flexibility to upload the answer, sir.
But then you will have difficulty in every like with this software. every platform, because the Gradescope is what, like, we have the license for it, and also it is very fast. I'm telling you, it is faster than other platforms. That's why we are using this. There,
Sir,
you were given only. Let me finish. You were given only two questions, most probably two or at most 3 pages. And in the final exam, there people have, like, students have in the previous semester, they have, like, attempted 15 questions for 3 hours, and then they have uploaded 20 pages within time. So the thing is that you just try uploading in that by on the demo exam, or that's why I gave you that the demo exam, right? So it's like, I can't help in this case because it's a technical thing. If I, like, if I allow you to, like, submit on some other platforms, then there it would be a mess up, because then only, not only you but other students should also be allowed. But then it's not like it would be like a mess up for me. So and I'm telling you that the grade scope is the one
सर मैंने सर
which
सिक्स
we all
ट्वेंटी
are.
फोर पे सर अपलोड करना स्टार्ट किया. हेलो सर.
Mhm. Yes,
हेलो सर.
yes, I can hear you.
सर ग्रेड स्कोर पर सिक्स ट्वेंटी फोर पे अपलोड करना स्टार्ट किया तो 6:36 पे हुआ जाके, यानी 12 मिनट अपलोड करने में लग गए. इतनी देर में अगर मुझे मिलती तो
No,
मतलब कोई और
no.
क्वेश्चन मतलब वो अच्छे से कर लेते हैं मतलब.
So
तो सर
अभी
बस ये टाइम
तुम्हें,
वेस्टिंग काफी होता है सर.
but see, so have other students also faced similar problem?
Yes, sir.
yes, sir.
तो
Many of
पहले
us.
दिन मेरे साथ यही हुआ कि फोन में सर मैं पीडीएफ ढूंढता ही रह गया, फोन में मिली ही नहीं,
नहीं,
तो फिर मुझे
PDF I
लैपटॉप
told
ऑन
you ना
करना
कि
पड़ा. फिर
uh, you can also do it like you can
तो वो
upload the
जो भी सर
JPG
ड्राइव
file.
की प्रॉब्लम हो या फोन की प्रॉब्लम रही हो, मतलब जो भी प्रॉब्लम रही, बट तो बाद में फिर
But
लैपटॉप ऑन
so
करना पड़ा,
see,
फिर
so
व्हाट्सएप
I
पे सेंड
cannot, I
करके.
can, so that's why I'm saying I cannot help in this case. In my
तो
email
सर
I
इसमें
clearly
हमारी क्या
mentioned that
गलती?
you have to, no, you have to be careful. This is not only in this exam I can hear, I can listen to you that this is your problem and I can try to help. But in other exams, nobody will ask you. If you are appearing for an exam, you should be like prepare for that. And you were given the instructions.
Sir,
I clearly mentioned that
सर
you make
ईमेल
sure that
ईमेल पे सेंड
there is
करने में
no
कोई प्रॉब्लम
technical.
नहीं.
Anyway, so next time, so what is the solution for this is that next time I will, instead of 5 minutes, I will give 10 minutes for uploading, so that and I'll keep, like, for every question at least 12 minutes I will give. So it's all, it depends on the question difficulty, but as I mentioned, that you will have to think and then write. Think properly and write properly, then only you will be able to score in this course. I mean, of course I
sir,
am there to help and in every sense, but you will have to think, otherwise there is no.
sir, I was
Yeah.
saying that while uploading question solution on Gradescope, sir, there is means there is a lot ambiguity. Means we have to, there is no any particular section to upload. We have to click on that. If it is if it is icon is going to come, then after it is we have to take the action.
Mhm. But then this is like, I can personally tell you how to upload, because I myself have tried and it was very convenient. I
Sir,
also shared this link.
but
But
in
then
demo,
it could be, see, it could be a network issue for you. It's not like it's not opening because there is a problem in the platform. Because others have uploaded and I have also tried, and people have been using this. So it is a network issue from your end or at your end. So network issue का तो मैं कुछ कर नहीं सकता ना. I
sir,
mean, what can I do in this
sir, then
case?
what we can do, sir?
So you try to see that where is the connectivity you have. You have better connectivity, and you try to see if you can, like, for this exam purpose, if you can take some other, like, package, uh, other recharge which has faster, more like a faster data pack. I mean, there are ways. It's like I can't help in this case. I mean, this is not something which I can really tell, okay, this you do, or you don't submit, or you submit somewhere else, or you submit, let's say, after 1 day. I cannot say this kind of statement. You try to do
Sir,
whatever you. In case if you are not able to, then in that case, you can send me on email. But that is like, um, there are situations where if you are not able to upload, then you like if you are not able to upload, then you would be considered absent, and then I will arrange like a different exam for you. I mean, those who are not able to appear or occur, or who are absent, and then it may be like a oral exam, maybe so we will see how to do that. But thing is that this is common, this is uniform to all. Instructions were given, you have to figure out how to sort out this issue, because it is not in my hand, the network issue is not in my hand.
sir,
Okay.
one more thing, sir.
Hmm.
Means it was not just in your examination, sir. It was also the same thing as also taken in place of OD examination, which was
Because I know,
yesterday.
because this we instructor cannot help in this case, na, because it's a network issue. How can we help in this case? I mean, I understand that you can't do anything, but you tell me that this is how I can do, because it's a network issue. It's not the platform that you are not able to upload on Moodle, but the network. You need to see that you have to find a point somewhere in your area that there is a network. Network is faster and related to other places, and you also figure out if some network, let's say Airtel is not working and some Geo is working, then you try to switch your network also, just for example first. Because
So,
it's the first exam, and there would be many more exams, not only for this course, for other courses also. Then how would you manage? Yes.
so sir, can we
Yes.
have some extra tutorial because of course we are following some books for the questions because a tute sheet is not enough. Tute sheets have question problem like solving, and we have to do some proof also. So sir, we have to cross check the answer and the approach whatever we are using. So can we
Hmm.
have so sir, because this problem I am having, ki if
So you
I
need
want.
problem sheet, extra problem sheets you are asking
Sir,
about?
problem sheets, sir, tute have problems like solutions, like solving. They don't have
Hmm.
proofs. What we have done in the quiz, that this kind of question was not in tute and was not in practice also. Sir, I have done from book. You referred Kunj, lekin, but sir, that was not enough because sir, whenever I tried, there was no one to cross check. So, sir, I
No,
didn't
but
get.
then there were no one to cross check. It's like if you are like, see, if you are solving a problem, you also realize that okay, you are going in a right direction. If not, then you take help of your tutors or your instructor. We are here to help.
Yes, sir.
If
So
you,
that's yes, sir. Can I mail it or
yeah, of course,
extra tune?
I already, yes, of course, you can email me whatever be your doubts. I already
Yes,
mentioned
sir.
that I can fix some other timing
Yes, sir. That's
free,
what
which
I'm
is,
asking.
yeah, which is free to free to us. We'll
Sir,
figure
it
out
will be very helpful for me because sir, I am literally having proof
so
problem and
then
sir, my
see, yeah,
yes, sir.
it's okay that this I already mentioned. You can just let me know when do you want to discuss, what you want to discuss. You first tell me that this is the problem. If I see that okay, it cannot be explained on email, then I'll fix like a meeting, and then I can explain on MS Team. So
Yes, sir.
it is doable. So these things I can do. I have already mentioned that you just tell me that these are the problems you are having related to your this subject. This I can arrange, because this is completely depends on me to arrange extra session and extra providing extra seats. These things I can do. But
Yes,
like network issue, I can't have. Anyway,
yes.
so let
Thank you,
us
sir.
move
Sir,
on. Yeah.
sir, just one more thing, sir. Sir,
Mhm.
means whatever the solution we have written in the examination, according to our point of view, it was right, sir. But we
So
are not able
that's,
to get
yeah. So
where
that's
we
why
are wrong.
I'm telling you where I have written that what kind of answers you have given in the quiz. So there were two questions. So let me just discuss the quiz 1 solutions. So there were two questions. The first question was you were given a matrix A of size 3 cross real matrix of size 3 cross 5 such that the rank of A is equal to 3. This was given. Okay. And then you were supposed to show that then there exists a matrix B of size 5 cross 3 such that AB is equal to I3, where I3 is the identity matrix of size 3 cross 3. This was the question, right? Now, there were many kind of answers I saw in the quiz from your side. Some of you, or not some of you, most of you have done what you have done. Most of you, you have taken a particular matrix of size 3 cross 5, which has some form without mentioning anything. You took some matrix A, which is like, let's say, some easy matrix, whatever of this form. Some matrix you took, and then what you did, you just, for this matrix, particular matrix A, you found this B matrix, and then you said that okay, there exists B, so AB equal to I. Now in whatever be your however difficult this question, you should know that this is not a correct thing. You are asked to prove for any given matrix A, and you are doing it for a particular example. Now in this way, if you say that you are not, you are nervous and you just wrote anything, then this, how this can be helpful?
No, sir, I did not
Because
get.
this is, no, so I'm telling you, it's for all, not for you. It's for everyone. Most of you have done 50, more than 50% students have done it in this way. Now clearly it is written that A is any matrix of size 3 cross 5. So whatever be your argument, it should work for any matrix. You are doing it for a particular example. Using a particular example, you can disprove, but you cannot prove. So there is a proof which is actually a disprove. Why a example, which we say that okay, give a counter example to say something is wrong, or but here I'm saying that you prove this and you are still doing it in the by taking an example. So this approach cannot help. So this is a wrong thing. So you should know that this is in whenever you are given this kind of statement, whatever you say, that should work for every given thing. The second solution was like you were given A of rank 3 of size 3 cross 5, rank of A is 3. This was given. Now most of you, what you did, I mean some of you, you assume that there exists B such that AB equal to I, and using this you show that rank of B is equal to 3. Some of you did this. You were supposed to show that there exists B such that AB equal to I, but some of you, what you did, you assume that okay, suppose that A is this matrix and suppose there exists B such that AB equal to I, then rank of B would be 3. And you were asked the reverse question. Obviously, if AB equal to I, then the rank of B, that you can see that it would be 3. Then using this, you were supposed to show the existence of B such that AB equal to I. So some of you did it in this way. Some of you try to convert it into a like a mapping thing, and then try to solve, but then the solution were again not like proper. So some of you, what you did, you assume that A is a matrix of from A is a map from R5 to R3. This you can do, of course, or you can, some of you also mention it in this way. So let's say T of X equal to A of X. But then what you did after this, you were supposed to show that since now the rank is 3, so that means the range is a onto map. Now this much you mentioned that this is onto. This is clearly from here because rank of A is 3. So it is very straightforward that it is a onto map. But then you did not use this ontoness. In order to use this ontoness, so what you are trying to show, actually you are trying to show the right inverse. So ontoness mein you were supposed to find some other map, let's say T tilde from R3 to R5, where you should relate this T tilde in such a way that when you do this like AB kind of thing, it should give you identity. So like you could have defined it like it's y, where y is x, where x is what? X is x equal to y, because y is onto, so you can always find such a x. And if you could have defined this in this way, then you can say that okay, somehow now you, if you look at this t tilde, it is identity. And now if you find a matrix of t with respect to the same matrix, same basis, then you could have found uh, this B matrix if you wanted to do it in this way by taking care of this basis. But what you did is that you mentioned that okay, this is the map, this is onto, but then you did not use this fact that this is onto in your further steps. Now this question you can solve by using these elementary operations. Like there was a question in the tutorial sheet about elementary matrices. So you know that so this is the solution. This is one way of doing it. A is a matrix of size 3 cross 5. Okay. Now, and rank of A is 3. This is given to you. Now you know that this matrix, what would be the row reduced form of this? So that means if you row reduce echelon form, so if you multiply or you apply finitely many elementary operation, or you can say that if you apply if you multiply with finitely many this elementary matrices, you don't know what is this A, so you just what you can say is that after multiplying with finitely many elementary matrices from left hand side, you will get row reduced echelon form of A. But then row reduced echelon form of A, what it could be? It could be like this one, and then you don't know what is there. Could be this one. Could be other form also. Like it could be this also. Um, this is also in that form. There could be some other possibility also. But what you can say is that. So let me write this as, let's say, row reduced echelon form of A. But let me write this A tilde. Okay. So when you multiply, what you can do, you can always multiply by some by some permutation matrix. Permutation matrix means some a matrix which is obtained by interchanging the rows or column of identity matrix. So you can always arrange it. What I'm saying is the following, that you can multiply with a matrix P. Let's say this is P from right hand side, and you can arrange these columns in such a way that this matrix is in this form. Okay. Now once you have this matrix is in this form, then let us call this matrix something. Okay, so let us now multiply. So once you are in this form, then assume that your B matrix is of this form, not B tilde is of this form. It's a identity matrix here, and then the last two rows are 0. Two students did it in this way. So
Sir,
when you just a minute. Now if you multiply with from here star with B tilde from right hand side, what it would be? It would be EK E1 A B tilde is equal to, when you multiply with B tilde from right hand side, it would be I3.
Sir,
But then it is not in the desired form. You multiply, now these are elementary matrices, these are invertible of size 3 cross 3. You can take the inverse. So what it would be, you can write it as A B tilde E1 inverse, E2 inverse, and so on up to EK inverse. But then you need AB equal to I. So now you again multiply from right hand side the matrices. So it would be E1, E2, and so on up to EK is equal to I3. Now this matrix you can call as B. So AB is I3.
Hello, sir.
Now all, yes.
Sir, I was doing in the same manner, but I stopped doing it. If I take a matrix A,
Mhm.
1 0 0 1
No, so
0,
that's what I'm saying.
sir,
You
then
don't take particular matrix A. If you are starting it by assuming that A has this form, then it is a problem.
So,
So
but
that's why I
sir,
explain.
we
Yes.
can take another form of this.
No. What I'm saying that you can, what you can say is that you start with the matrix A, but you cannot start with the matrix A which is like in a particular form. You can always, you will have to say that you can always convert this A, or you can transform this A into this kind of matrix by using these elementary operations. Then only you can say. But if you start with a matrix which is in this form, then it's like you are doing it for that particular.
Sir, you have written here that ek dot e1 ap, and if we have in the third row, if we have
Hmm.
another like any number, then
Hmm.
what will happen? Then how we will find the matrix B?
No. So that's what I'm saying. No, you can always multiply. You can always rearrange this column. What you know. So what you know from the row reduced form, that row reduced form of A will have these three columns. One is this one, other one is this one, and third one is this one. The other two columns, they can be like they can be shifted to this side. They can be here in the other side of uh, here or somewhere in
So they
between.
can be non-zero also.
They can be non-zero also. That's why I'm saying. So they can be non-zero also. They can be here, but then you can always arrange these columns. So let me call these then E1, E2, E3 just for understanding purpose. These are E1, E2, E3. Three columns would be there. These columns would always be there in the row reduced form. So what I'm saying is that you can always multiply with a matrix P, which is a permutation matrix, that using this you can interchange these columns of this matrix, and you can shift these E1, E2, E3 at first, second, third place, just for simplicity. You can always do that. You just take an example wherever you have this kind of thing, you can always multiply with a P. So this P permutation matrix is useful for interchanging rows or columns. When you multiply by left, it will interchange the rows, and when you multiply from right, it would interchange the columns. And then you can always get a matrix which is in this form.
So
So
for like
two of you did this way. Now, so
so,
so you think about it. Just a minute. You think about it. I
सर
don't.
सर
Yes.
कैलकुलेशन में पी मैट्रिक्स कहाँ गया?
P matrix is there, no? This P. So this P
सर
is there,
उसके
right?
नीचे वाले
Yes. This P matrix is there, right?
तो सर इस पी को हम रिमूव कैसे करेंगे? ये
You
नीचे
don't
वाले
have to
स्टेप
remove. You don't have to remove. You just assume that this is your B now.
ओके सर
So
ओके
AB side. Okay. Anyway, so you think about it. I don't have much time. I have
sir,
already
sir,
lost 30 minutes. Just a minute. Let me move on. You can ask later on. So the same thing for the second question. Second question is much more straightforward. Most of you tried that in the right direction, but there were still answers where you took. So again, you made similar kind of mistake. You were given a vector space V which is of dimension 8, and there was a subspace W of V which was of dimension 5, I think. And then you were supposed to define two map T1 from V to V and T2 from V to V such that null of T1 is equal to W, and the direct sum of null of T1 and null of T2 is equal to V. This was given to you. Now, some of you, what you did, you assume that, let's say, okay, V is equal to R8. Assume that this is the case, and then you did it for this by choosing this particular map for this V equal to R8. So you basically solve this for R8. Some of you mentioned that since V is isomorphic to R8, then we can do it in this way. Actually, this is true that V and R, every higher dimension vector space is isomorphic to like Rn. But the problem is there, or Fn, depending on the field, R or C. Now, here it is fine that they are isomorphic, but you were asked this question for V, and you are solving it for other. Now, if you say that, okay, since V and let's say R8 are isomorphic, so we just define it for this R8, you can do it for this, but then at the end you will have to transfer this map again in the form of this from V to V. Because if you want to use this isomorphism, then you should say in this way that okay, this T, let's say this isomorphism is denoted by, let's say, G. So this is isomorphism from V to R8. Okay, and now you are trying to define this T map, let's say T1 from R8 to R8. Okay, you want V to V, right? So then you should again use this isomorphism, that means G inverse. Then this G inverse will take you from R8 to V. Now you consider this map, sorry, this map G T1 G inverse. This will be your map, which that you can use by using this isomorphism. You can say that this is map from V to V, and then you see whether it satisfies the things or not. If you want to use the isomorphism, because ultimately the question is asked for V. You can use isomorphism, but you have to use it in the proper way. So that is also not true, not correct if you do it in this way. So this is very easy. And also some of you, what you did, you took a basis for V. First you took a basis for V, let's say V1 to V8. This is the basis of V. And then you say, okay, let W equal to V1 to V5. This is the basis of W. Now the problem is that if you do it in this way, there is no guarantee that this would be a basis. So this is not a proper way or correct way of writing. But I mentioned in the class that you always take a basis of a smaller set and then you try to extend. So what you should have done is that you should have taken a basis, let's say V1 to V5, a basis of W, and then you extend this basis V1 to V5, let's say V6, V7, V8 you have added to V, so that it becomes a basis of V. Now you know how to define what you want. You want T1 from V to V such that null of T1 is equal to W. So you send this Vi equal to 0, where I equal to 1 to 5, and then T1 Vi equal to, let's say, Vi for I equal to 6, 7, 8. Now this is the idea, but the proper actual map would be what? You take this, you express any vector in this form, and then the map would be alpha I equal to 6 to 8. This is your map. You don't have to prove that this is linear, and the way you have defined, you can also easily say that null of T1 is equal to the span of V1 to V5, so it is W. Similarly, you can define T2 in this case. You can reverse the role of this V1 to V5 and V6 to V8, and then the way you are defining, you can make sure that null space of T1 is and direct sum of null space of T2 is equal to V. So most of you did this in the correct direction. The only thing is that you did not write it in properly. So I've deducted some mark for this so that you don't make the same mistake in the next exam. So the point here is that you should understand, you should learn how to write. Writing is very important in mathematics. If you just write the next, I mean the step which should come after the previous one, if you reverse the steps, the order of the steps, the answer gets changed completely. So you should be careful this way. I will keep in mind that you need extra time, so I will try to give some more time in the minor exam. But the questions, as I mentioned, they won't be difficult, but you will have to think. You will have to think. It would be completely related to what you are doing in the class or in the tutorial. It would be based on that, but you will have to put some effort in thinking. Okay, so let's move on. We have already spent a lot of time on this.
So,
If you want, so just a
so
minute. If you want, just a minute. If you want, I can give a session, like an extra session, or maybe I can ask my TAs to give an extra session, like other than this tutorial class, just to discuss the problems based on whatever you are having. You can discuss with them, let's say for 1 hour some other time than tutorial and lecture. If you want, I can do that. So just let me know, or I can also be there for your discussion. So we can do this way also. Just let me know that you know you need an extra session for this problem discussion. Yes.
सर क्वेश्चन नंबर फर्स्ट का निगेशन बता दीजिए, हम कंट्राडिक्शन से प्रूव करना चाह रहे थे।
कंट्राडिक्शन से
प्रूफ करना चाह रहे थे, इसका निगेशन क्या होगा?
So you are saying that so the negation would be, so see, okay, so let us write the negation of it. So A is a 3 cross 5 matrix and rank of A is equal to 3. Then you have to show that there exists B 5 cross 3 such that AB equal to I3. Okay, so now if you if you write the negation of this, the negation would be like, so there are two things, negation and contradiction. Okay, so
Sir,
negation
I just want to negation of this statement.
So the negation, in the negation, what is the negation? So if you have P implies Q, two statement, the negation would be not Q implies not P kind of thing, right? So now here in this case, you are given a matrix of size 3 cross 5 with rank 3. Then there exists B such that AB equal to I3. Okay. So now what would be the negation of this?
For all.
So the there exist will be replaced by for all.
Sir, this is counterpositive, right?
If this is counterpositive, right? Counterpositive. So here, if you want to write the negation of this, negation is you just say that okay, you replace the there exists for all in this case. So what would be the negation? So if A is a matrix of size 3 cross 5 such that for all B AB is not equal to 3. So let's say A is a matrix of size 3 cross 5. If for all B, AB is not equal to I3, then this implies that rank of A is not equal to 3. Okay. Is it okay?
Yes, sir. Clear.
So in the negation, what you do is that you just replace the these quantifiers. There are two quantified universal quantifiers. These there exist and for all. So you replace there exist by for all and for all by there exist. Right in the writing negation, and the equality is also like reverse, gets reverse. So just keep these two things in mind, and then you can write the negation of any statement. If you want to prove it by contradiction, then what you have to do is that you say that okay, suppose that for all B, AB is not equal to I3. Then you should be able to prove that rank of A is not equal to 3.
Yes, sir. That's what I am trying.
Okay. Okay. So let's start today's lecture now. So we can move on now. Today is lecture, I think 11. So what is today's lecture 11?
Yes,
So in
sir.
the last class, in the last class, we started linear functionals. So let me recall what we did in the last class. So what is linear functional? So if suppose we have a, so we are starting linear functionals. Suppose that we have a vector space over field F. Okay, then a linear map from V to F is called a linear function. Okay, so I'm recalling this. Then a linear map from V to F is called a linear functionals. Okay, Now we know that the collection of all linear map or linear transformation both are same. So the collection of all linear transformation from V to F, that means this set, we know what is this. This is the collection of all linear transformation from V to F. For this, I'm using this notation just for the linear functionals. So this is collection of all linear functionals on V. So this we denote by V dash. Okay. So this V dash is known. Sometimes this set is also known as dual space. Dual space of V. Okay. Now one thing is clear. So here so far I have not mentioned that V is finite dimension or not. But if V is finite dimension, then you know that the dimension of this set V dash is also n, because it's the collection of all linear map from V to F. And if suppose dimension of V is n, then you can say that dimension of V dash is also n, and therefore it is also finite dimension. So if V is finite dimension, then V dash is also finite dimension, and the dimension is same. Okay. Now we saw some examples also, and then at the end of the lecture, the previous lecture, I made some observation. So let me recall that observation again. So observation is the following. Suppose that we have a finite dimension vector space V. Okay. So now onwards, sometime whenever needed, I will mention that V is infinite dimension. But otherwise, I will most of the things I will talk about finite dimension also, only in this case for the linear functions. The reason is that for infinite dimension, you may need some other like details, and those things you will learn in function analysis. So we'll try to focus on understanding these concepts for finite dimension case. The extension of these results, some of these results will be done in function analysis when you learn this function analysis. Okay. And for understanding, we'll keep our focus on finite dimension space. So let's say that V is finite dimension vector space, and n is the dimension of V. Since n is the dimension, so let's say that we have a basis also. Let's say V1 to Vn. Then I mentioned in the last class, that then for each I, so this is the first observation, that for each I, there exists a unique linear functional. Linear function means fi in V dash. So for each I, there exists a unique fi in V dash in the dual space, such that fi of Vj is equal to del Ij. What does it mean? It means that 1 if I equal to j, and 0 if I is not equal to j. Now this is true because we can always define such a linear map. We have seen this, right? So for each I, you can always find this fi. So is it okay up to this much? We have done up to this in the last lecture. So is there any doubt in the existence of this fi?
No, sir.
Okay. So now so up to this we did in the last class. Now let's say, so if I take any vector v, so let's say for any v in the vector space v, since v is in the vector space v, I have fixed a basis for this, so I can write this v in this way, alpha I vi, I equal to 1 to n, right? Now if I want to see what is fj of v, because fi's, they are the linear functions, that means they are linear transformation from v to f. So I can do this. What it is alpha I. I can take this j inside because it's linear. So fj vi I equal to 1 to n. So what it is? So what is this equal to?
Alpha J.
Alpha
This is
J.
just alpha j, because these fi's, they satisfy this condition here. So this is alpha j. So what you can say from here, that now you look at carefully, these functionals, these fi's, they are of important use. They are very important for us. Why? Now you look at here, what it gives. So if I apply this fj on any vector v, then it gives me the jth coordinate of v when v is written as a linear combination of basis vectors v1 to vn, right? So that means these, these fi's, basically these fi's, sorry, these fi's are the coordinate function, coordinate functions for basis v, right? Not only this, these three, these functionals, these f1 to fn. So see, while talking about this function, I have fixed a basis b. Depending on this basis, I have defined these fi's, which are satisfying this, which are the actually the coordinate functions. These functions f1 to fn, they form a linearly independent set in v dash. So you can verify that this f1, f2, and so on up to fn, this set is linearly independent in v dash. Okay. Now how to do check this? So these are functions. Okay, we will use the usual definition. So let's say check whether it is linearly independent or not. So let us suppose that alpha 1 f1 and so on up to alpha n fn, this is equal to 0. Now what we can do from here? Can you tell me how to show that this is linearly independent? How to show these alphas are 0? So this f1 to fn,
सर बाय अप्लाइंग
फॉर ऑल वी के लिए सर इसलिए ये सब जीरो हो गए,
yes,
क्योंकि इन
yes,
पर्टिकुलर एक 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 के लिए जीरो हो रहे सारे। तो जैसे कि अपन अल्फा वन लेंगे, सॉरी मतलब पर्टिकुलर वी वन लेंगे तो सिर्फ अल्फा वन जीरो हो जाएगा, सॉरी मतलब
yes,
बाकी सारे जीरो हो जाएंगे और
yes, I understand, So he's saying that since fi's are functionals, so if you take this linear combination, this is again a functional. This is again a functional from V to F. So it's a linear transformation from V to F. It's a linear functional again. Now this implies that alpha 1 f1, if this function is 0, means this function is 0 at every point. So you can say that from here this alpha n fn v equal to 0 for all v in V. But in particular, if you apply, if instead of v, if you in particular you take the basis vectors, then what you get? For example, for any j, if you apply f1 vj, alpha n fn vj, in particular this is 0 for all j equal to 1 to n, right? But then what it is? It is just,
Alpha
what is the
J.
left hand side?
अल्फा जे इक्वल्स टू
Alpha j equal to 0, and this is true for all j equal to 1 to n. Now this implies that this set f1 to fn, this is a linearly independent set. So what we have seen, so what we have done so far, what observations we made, we have a vector space and we fix a basis for this. Based on this basis, we found these coordinate functions or coordinate functionals. They satisfy this thing, and these functionals are actually linearly independent. So since we know that if v is of dimension n, then v dash is also dimension n, and we have found n linearly independent vectors in v dash. So that means these things. So that means this form a basis for v dash. So this is linear independent set. In fact, you can say that this forms a basis for v dash. This basis is called the dual basis of B. it's a basis of dual space, so it is called the dual basis. I'll tell you why it is called dual space, but just let me finish this definition first. Formally, we can define what is a dual basis. So this is the observation we made. Now let me define out of this observation. Let me define this. What do we mean by a dual basis? So suppose that, so let V be a finite dimensional vector space and assume that n be the dimension of V. Okay. And you remember what we did? We fixed the basis for V first. So let's say we have a basis V1 to Vn. For V. Okay. And assume that we have a basis for V dash also. Let's say for V dash. So let's say F1 to Fn. This is the basis of V dash. So we have a basis for V, we have a basis for V dash. Then this basis V dash is called the dual basis. The dual basis of B if Fi Vj is equal to del Ij. That means 1 if I equal to j and 0 if I is not equal to j. Alright. So if we have V and V dash, two bases, one for V, one for V dash, in this way, then this B dash is called a dual basis of B if this condition is satisfied. That means Fi of Vj is equal to del Ij. Then we say that it is a dual basis. Okay. Now we will see how to find and how to do this, how to do things with this dual basis. But before that, let us make this observation. So suppose that we have a, let B dash, which is let's say F1 to Fn, I am fixing in this way, be the dual basis of B, which is of the form B1 to Bn. Okay. Then for any V in V dash, what we have V equal to I equal to 1 to n Fiv Vi and F is equal to Fvi Fi equal to, and for any V in V and F in V dash, we have this. So how it is proved? The proof is very straightforward here, or the observation. The proof is not difficult to see. It follows just by definition of the dual space. What we have. So let's say, suppose that we have a vector in V. Then since we have a basis for V, we can write this V in terms of this basis vectors for some alpha in F. Now, since B dash is the dual, then we know that these Fi's, these functions Fi's, they are actually the coordinate function because they are the dual. This is the B dash is the dual basis of B. So they are the coordinate functionals. So B dash is dual to B. What we can say from here, we have this alpha is instead of alpha I. So if you just go back to your observation here, what is this alpha j? Alpha j is just abs jv, right here. So just use this instead of alpha I can write fiv vi I equal to 1 to n. So this is very straightforward, the first thing. The second, now suppose that we have a we have a we have a functional, we have an element in the dual space. Then again, what we can do then, what would be f of v? F of v would be, so let me write it in this way. F v is what? From here now I can take what is this v? So v is I equal to 1 to n fiv vi. Now since f is linear, I can take this inside. What it would be? It would be fiv f of vi I equal to 1 to n, right? Now what I can do from here, since this f is a linear function, fi is a linear function, so these are just scalars. These are just scalars. So I can just, I'll first write the this f of vi and then this one. So I'll just reverse the order here. So this thing is I equal to 1 to n f of vi fiv. But then this is true for all v. So what I can say from here is that this is, sorry, this is equal to I equal to 1 to n f of vi f fi, sorry, and then v. And this is true for all v in v. Right? So what we have that f of v is equal to this thing of v. So let's say this is g of v for all v. So that means f is equal to g. So this implies that f is equal to I equal to 1 to n f of vi fi, right? And this is what we were trying to show. So what does it mean? It means that if I take, if we have a basis and if we have a dual basis, if we have the dual basis of it, then we can write every vector v using the dual basis, because we know that the coordinates are nothing but the these fi's are nothing but the coordinate function. So if we know these fi's, then we can quickly write this v, because these scalars we know, these coefficients or these coordinates we know, so we can quickly write this v. Not only that, we can also write this f. So if we know the dual basis, then this, for any f in the dual space, we can write it as a linear combination of these, or we can express this f in terms of the dual basis. That means this fi's, where these scalars are also known to us. These scalars are easy to find in this case. So it says that if we have a dual basis, then we can easily write any vector in V and any vector in the dual space. Okay. So, okay. Now, let me just make one more observation here. Let us make one more observation. Suppose that we have a vector space for F. Okay, and let's say we have a basis of it. Basis of V. Okay. Now, can you, like, let's say if I fix let's say A1 to AN, these scalars I have fixed in Fn. Okay. Now, can you define a functional G from V to F using these AIs? So can you define a linear function on V using these AIs? Can you do that?
Yes, sir, we can.
How to do that?
Sir, G of Vi equals to AI. Simple.
Yes, you just send these VIs to AIs. So G of Vi equal to AI. So in general, if you want to write it as a map, then what it would be? Then you can take any any vector here.
सर लिनियर कॉम्बिनेशन से
Yeah. So you just write it as alpha I vi. But then this, as you said, g of vi is just ai. So you can write it alpha I ai. So you can do it for any a1, if any n tuple, if you take in Fn, then you can always define a linear function on this. So what you can say that then for any a1 to an, this n tuple in Fn, you can always define a linear functional based on this tuple on V. Okay, so then if you do it on this way, then G is in V dash. Now, what would be the converse of this? What would be the converse of this? I want to ask so this is straightforward. This we have seen. Now, what would be the converse? What about the converse?
Sir, if G belong to V star, then we can find a V belong to V.
V belong to V? No. So you are saying that if I want to write the converse of this, you are saying that if G is in V dash in the dual space of V, then what you have to show?
Then we can find an n tuple in the Fn field such that we have a basis for vector space V, that is V1 to Vn.
Not this way. This basis is fixed. So up to this is fixed. So it's like from here. So you have to tell me the converse of this statement. So if so what we did for any a1 to an n tuple in Fn, we can find a G such that G of V is equal to summation alpha I ai. Now converse would be if G is in V dash, then we can find, or we have to find this n tuple such that G of V is in this form. Okay, so using this we have to find this AIs. What we did so far, using this AIs, we found this G. Now using this G, we have to find these AIs. That's all. So conversely, what we have to do, we conversely let G be any functional on V. Then what I have to show? I have to show the existence of these AIs, but let's see how to find that. So if I take any V, then I can write it in this alpha I vi I equal to 1 to n. Then this would be G of, alpha I G of vi I equal to 1 to n. Now, can you tell me what I should choose here so that what AIs I should choose this n tuple?
GBI.
GVI, because G is non. So this I can do. So now I will go back to this and I will complete the statement. So let G be in a linear functional on V, and if I set AI as G of Vi for I equal to 1 to n, then G of V is equal to this, and then this is equal to alpha I G of Vi, and this is equal to alpha I AI I equal to 1 to n. So what is the conclusion of this observation? The conclusion is that every linear functional on a finite dimension vector space V over A has the form, let's say star. Let us call this form star. So that means G of V would always be can always be written as summation alpha I AI for some AI. So every linear functional on V has this form. So let us take one example now. Let us take one example. So suppose that we have three three real numbers, okay, and they are distinct. So let's say we have this T1, T2, T3, they are distinct real numbers, okay, and consider V as the space of all degree less than equal to 2 polynomial functions, okay. So these are the space of degree less than equal to 2 polynomial function. So by the way, so let me just make it clear. What is this P2R? We have done this, right? We have already talked so many things
Yes, sir.
about P2R. What is this?
Yes.
Polynomial of
Polynomial of
degree
degree
less
less
or
than equal
equal
to
X-ray
2.
space
to
of polynomial
where
of degree
field is R.
less than.
Yes, so less than equal to 2. So all polynomials of degree less than equal to 2. All polynomial functions of degree less than equal to 2. But is it a vector space?
Yes, sir.
Yes, sir.
Yes, sir.
But does it have 0?
Yes, sir.
Yes, sir.
Yes, sir.
How?
So
Zero
coefficient we can take 0.
zero
All
polynomial.
coefficients 0.
No, so that you said that take all polynomials of degree less than equal to 2. So then
सर
you have
जीरो
taken 0.
-1 या माइनस इन्फिनिटी कंसीडर कर लिया जाता है ना.
No. So what I'm saying is that I understand. I know this. So what I'm saying is that I want to make just point out that when you say that degree less than equal to 2, that means 0, 1, 2. But then you have to include 0 also. Then you say that degree less than equal to 2, including the 0 polynomial, the 0 element. Then it is a vector space. So there, just to be more precise, say that less than equal to 2 and including 0 also. Okay. Now for I equal to 1, 2, 3, let us define these functions or this transformation Li from this space P to R this way. How it is defined? If I take any polynomial, let's say P here, then I will send it to P Ti. Okay, so that means this is the polynomial evaluation at point Ti. Okay, so you evaluate every polynomial at point Ti. So for all I equal to 1, 2, 3, you define these three functions from P to R to R. Now you can verify that these Li for each I, they defines a linear functional. They are in fact linear functionals on V. So they belong to the dual space. So for I equal to 1, 2, 3. This you can verify. Okay, this is very easy to verify. So this L1, L2, L3, they belong to the dual space. Not only that, these L1, L2, L3, this is a linearly independent set. Or in fact, you can prove that this L1, L2, L3, they form a basis of V dash. Now, what is the dimension of V dash in this case?
3.
3.
3.
And so therefore, in order to show that this form a basis, we just have to show that this L1, L2, L3, they are linearly independent. If we do this, then we can say that they form a basis. Right? So let us show that they are linearly independent. So how to show they are linearly independent? Again, use the definition. So let's say alpha 1 L1 plus alpha 2 L2 plus alpha 3 L3 is equal to 0. But since L1, L2, L3, they are they are linear functional, their sum is again linear functional. So we are saying this is 0. So that means this is 0 at every point in P2R. That means every polynomial in P2R. So this is true for every polynomial P. You can write it in this way. Right? So now what I should do now? now again, by definition, L1P is PT1, L2P is PT2, and so on. So I can write it again as, just by use the definition of these L1, L2, L3, it would be PT2 plus alpha 3 PT3 equal to 0. And this is true for all polynomial P. Now you tell me what I should do now in order to show that these alphas are 0.
We can take a polynomial x minus t2, x minus t3, then alpha 1 will be 0.
X minus
t2 multiplied by x minus t3.
x minus t1, x minus t2, x minus t3. You are saying that. So basically, you take 3 polynomials. So you have to show that this, since this is true for all polynomials, so you have to choose some particular polynomials, and then using them, those polynomials, you have to show this, these alphas are 0. This is what you have to do. So you can take any 3.
So since we are given t1, t2, t3 are distinct real numbers, and p is a polynomial of degree less than equal to 2, then it will have at most 2 roots. Then either p of t1 and p of t2 will be 0, and third one will not be equal to 0. If we look at in this way, then alpha 1, alpha 2 and alpha 3 should be equal to 0, so that this equation follows.
So yeah, so I understand what you are saying. So you are taking that, you are saying that these PIs, they belong to these P2R, so they are all polynomial of less than equal to 2. So you, if you want to say that, then you just say that, okay, this is a polynomial of the form, let's say a nor a1 a2, like a nor plus a1x plus a2x square. Similarly this one, and similarly this one. Then you collect all these coefficient, and then you try to show. So the same way you, so what you can do in particular, you can take some, this is true for all polynomials, so you can take some particular polynomials and you can show, because this statement is true for all P. So what you can do, you can take, let's say, these polynomials, let's say 1, x and x square, these 3 polynomials you take. Then if you do this, then what you get, the first one will give you alpha 1 plus alpha 2 plus alpha 3 equal to 0, right? The second one will give you alpha 1 t1 plus alpha 2 t2 plus alpha 3 t3 equal to 0. And the third one will give you alpha 1 t1 square plus alpha 2 t2 square plus alpha 3 t3 square equal to 0. So this is like a, this t1, t2, t3, they are known to you. Only unknowns are alpha is here. So from here you can write a homogeneous system in this. So it would be 1 1 1 t1 t2 t3 t1 square t2 square t3 square, and then alpha 1 alpha 2 alpha 3 equal to 0 0 0. Now this homogeneous system, from here you can say that this homogeneous system has only the trivial solution, because these t1 t2 t3, they are distinct. So since,
Yes.
yeah, since t1 t2 and t3, they are distinct, this implies that alpha 1 equal to 0. Yeah, and this implies that this L1 L2 L3, they form a basis for this space. Okay, now, so if you recall what we did, so in the beginning we started, while defining this dual basis, what we did, so if you look at this observation here, what we did, we started with a basis. So we have suppose that we have a vector space. If suppose we have a basis B for the vector space, then for that we found a basis for the dual space. So that means the dual basis. So we have a basis for V, then for that we found a basis which is the dual basis. Now I ask the converse question. Now suppose if we have a basis for V dash. So let's say we start with a basis of V dash, then can we say, or can we find a basis, let's say we have a basis B dash of V dash of the dual space. Can we find a basis B of V such that this basis B is uh, such that the basis B dash is dual of this basis B. So it's a converse question. So start with a basis B dash of the dual space. Can you find a basis B of V for which the given basis is the dual? So this is the converse question. Okay. So what I'm saying is the following. So
हेलो सर
yes.
सर हमने सर पी एक्स इक्वल टू 1x एंड एक्स स्क्वायर ही क्यों लिया, कुछ और क्यों नहीं?
तो कुछ भी ले सकते हो. That's why I'm saying ना.
सर
You can take
सपोज मैंने ले लिया
polynomials.
1 minus x and 1 plus x, then what?
So then you try and see what you want to do. You should find three polynomials in such a way that you are able to show that alpha 1, alpha 2, alpha 3 are 0. So the first
सर हम
choice which comes,
पर्टिकुलर ले रहे हैं और बोल रहे हैं कि अल्फा इज आर 0, तो सर कोई मे बी सर समय गेस कर जाए यहाँ पे रेडी आ जाए.
wait. ऐसे एग्जिस्ट कैसे कर जाएगा? Look at the statement, the steps we are following. What we are saying that we want to show that this forms a basis. Since there are three elements, we just have to show that they are linearly independent. In order to show linearly independent, we just use the definition. The definition says that you just look at this linear combination, and then you show that this linear combination is 0, implies that all these alphas are 0. Now this L1, L2, L3, just a minute. This alpha and L2, L3, they are linear functions. So their sum is also a linear function. So that means it is a map from V to F. We are saying that this function is 0. That means function is 0 means its value at every point is 0. That means this is 0 for all P, because the points are P, the vectors are P in V. So for all polynomials. So this statement is true. This is what we have obtained from here, that this equation is 0 for all polynomial. Okay, now this is true for all polynomial. So whatever polynomial I choose, this statement is going to be true. Now I am choosing three polynomials, 1x, x square, just to show that this alpha n, alpha 2, alpha 3 are 0. So you can choose any three polynomials and try to show that try to get three equations in three unknown. So try to obtain a homogeneous system in this form and show that these alphas are 0. So you can take any three polynomials. I have taken this 1x, x square because these polynomials come to our mind first, right? These are the easiest polynomial. 1x, x square, we are familiar with them. So I have taken these three, but you can take any three polynomials as long as you are able to construct this system of linear equation. You can it's okay. You can use them and you can show that this alpha is 0. So there is nothing special about this.
मेरा क्वेश्चन सिर्फ ये है कि हम जो पीएक्स चूज कर रहे हैं उसकी गारंटी कहाँ से आ रही है कि मतलब हम जो चूज करेंगे वो एलआई ही देगा, तो वो गारंटी
कहाँ से? So that's what I'm saying. It's because these 1x, x square, they are allies, ना?
तो इसीलिए मैंने कहा कि 1 minus x and 1 plus x एलडी ले लें अगर तो क्या होगा?
So then you try. That's what I'm saying. Until unless you try, you won't understand your thing. You just take and then try and see what you get. If you answer yourself, then you will learn more. You just take an example and see what happens, right? So this the easiest thing is that you just try and see what happens. Okay, so the question here, maybe we'll answer this question in the next class, but let me put up this question first. So the question is, what is the, first let me ask this question for this example and then we will generalize it. Okay, so the question is, what is the basis of V? In this case is P2R. What is the basis of V of which this given basis L1, L2, L3 of V dash is the dual? Okay, or in other words, what you can say, you can just rewrite this statement. You can ask the same way, the same question in this way. Can we find can we find, let's say P1, P2, P3 in P2R? So let's say basis of V such that can we find P1, P2, P3 basis of P2R such that Li Pj is equal to del Ij. Okay, then you can say that these are this L1, L2, L3 is the dual of this P1, P2, P3. Now, can you do this?
Yes, sir, can.
So you
Yes,
look
sir.
at
Yes,
the
sir.
here. Yes, yes. So this left hand side is what? It is just Pj Ti. So you just have to see, can you find polynomial P1, P2, P3 such that Pj Ti is equal to del Ij? Yeah, how to do that? I mean, can you give me P1, P2, P3?
सर वो सारे पोलिनोमियल ले सकते हैं जो मतलब L1 L2 L3 को लीनियरली इंडिपेंडेंट बना रहे हैं, वो बेसिस बनाएंगे P2 का.
So you need to find P1, P2, P3. You can take if you take any polynomial that may be a basis for P2R, but that may not be a basis that satisfy this thing. You need
Sir,
to
I
just
just
a
say
minute.
कि ये जो लीनियर कॉम्बिनेशन बन रहा है यहाँ पे, और अपन ने जो पोलिनोमियल ली है 1x x², तो इस टाइप से अगर अपन कोई भी पोलिनोमियल लेते हैं और इस इक्वेशन को सेटिस्फाई मतलब कि अल्फा 1 अल्फा 2 अल्फा 3 उसके बिहाफ पे 0 आते हैं, तो वो बेसिस बनाएगा P2.
Yes, you can do it in this way.
सर हम L1 के लिए वो सारे PJs ले सकते हैं जिनका रूट T1 होगा, और L2 के लिए वो सारे पॉलिनोमियल्स ले सकते हैं जिनका रूट T2 होगा.
Right. So basically, have you seen this kind of polynomials? Like, okay, so let me write these polynomials. So this polynomial, this P1, P2, P3. I'm giving you this example, but after this, I will ask you a general question, and then we will see how to find them. Okay, for a given function, how to find like a basis which is dual to it. So if I take P1, so these polynomials we can take as follows. These polynomials, just for this example, I am giving you directly, are given by P1x. I can take x minus T2, x minus T3 divided by T1 minus T2, T1 minus T3. You just have to find a degree, a polynomial of degree less than equal to 2, such that Li Pj is equal to del Ij. Now you see here, or that means Pj Ti equal to del Ij. Now for this P1, clearly this polynomial P1 is 0 at T2 and T3, and it is 1 at T1. So this is fine, and it's a degree 2 polynomial. So this P1 will work. Similarly, you can define this P2x. This is x minus T1, x minus T3, and then T2 minus T1, T2 minus T3. So P3x is x minus T2, T1, x minus T2, then T3 minus T1, T3 minus T2. So the answer of this question for this example is that we can do that. We can always find, or we can find P1, P2, P3 such that these L1, L2, L3 are the dual of this P1, P2, P3. Okay, so the answer is that then this P1, P2, P3 is a basis of V. You can verify that this P1, P2, P3 they are linearly independent. This follows because of this property that Pj Ti is equal to del Ij. So they are linearly independent in V. V is of dimension 3, we know, so they form a basis. So this P1, P2, P3 is a basis of V, of which this L1, L2, L3, this is the dual. Okay. So this question we have settled for for this example by giving P1, P2, P3. Then in the next class, we will ask this question. So let me put up this question and then we stop. So the general question is, so the question in general is as follows. For a given basis, V dash, let's say F1 to Fn of V dash, can we always find a basis of V of which B dash is the dual? Okay, so we will answer this question by considering the double dual of V. That means the dual of V dash. Okay, so we will answer this question in the next class. So we can stop here. So if you have any doubt, you can ask. So I'll upload a tutorial sheet based on these linear functionals today.
Hello, sir.
Yes.
Sir, can you provide us questions like that you have asked in exam proofs writing, like simple proofs writing, that kind of little difficult or?
Yes, I'll see that. I'll do that. I'll send at least I'll. The problem is that constructing your own questions, I mean, for exam itself is very difficult. But I'll try to provide you some questions uh, where you have to use your whatever you are doing, and you can try them by writing their solution. You should also try. You can try any, like you can also take any textbook and try to solve, or you can also try to like write the tutorial problems.
So what in a textbook such type of questions is really fine, like you ask the proofs writing, like this kind of proofs writing. They have
No,
a
so
standard proofs writing, but this kind of proofs
yeah.
writing.
Okay, fine. So I'll give you some questions. I'll try to like provide you some questions so that you can try them.
Okay, so thank you, sir.
Okay, I'll send this list of questions.
The
Okay.
next class will be after minors.
So next class is on Thursday. So when the exams start?
Sir, our exam started at 20th.
20th, na? So today is 14th. So I think the Thursday is a teaching day, na?
So
Sir, in
yes.
the calendar, I have seen holiday from 16th, so that's why I'm asking.
Okay, I don't know. So if it's a holiday, then it's a holiday. If it's a teaching day, then we'll have a class. Okay. So if it is not a holiday, then we'll have a class. If it is holiday, then anyway we won't have. But I will provide you I'll upload a tutorial sheet. I'll also upload some extra questions just for your practice purpose. And
Yes.
you might be aware that your exam would be, I think, on 23rd. So we are in A slot. So A slot means it would be in the second half of 23rd of September. Anyway, I'll confirm this and I'll circulate an email regarding your minor exam also.
Sir, you told us we can mail to Dean about that date because there are some student who's having their bachelor's exam also on 23.
Yes, but then that I mean that approval you have to take from the from the higher authority. It's not like this exam, but other exams will also be you want other exams also to be shifted, right?
Yes, sir.
Not only this, but other exams are also want to be shifted, but then that decision should come from above.
So can we mail or not?
Yeah, you can, whatever you can email to the email which is provided to you, and then you
Yes.
can tell them, and you do it as soon as possible, because once the exams are closed, it would be difficult for them to shift, if at all it is possible.
Yes, sir.
Sir, tutorial from 11 or 2 p.m.?
No, tutorial would be from 2, because I think your tutors are not free.
Okay, sir.
So it would be from 2 to 3.
Okay, sir.
All right.
Thank you, sir.
Yeah, you're welcome.
Thank you, sir.
Excuse me, sir.
Yeah.
Sir, I wanted to ask something. May I?
Yes, yes.
Sir, sir, like what you were discussing in the class on page number 1 regarding question number 1 of the quiz 1. Sir, like you were saying that